So my dear students, you are most welcome for this lesson. Today we are going to have a look at formation of ray diagrams, and I think in the previous lesson we talked about types of lenses, talked about the focal point, we talked about different rays that pass through the lens and how they behave. So today, in particular, we are going to start with important rays that lead to the formation of diagrams. So those rays, sometimes in other books, you will find them being called rules. So rule one, that is so we are going to compare convex lenses and concave lenses. So rule number one, that is the ray that is parallel to the principal axis. So that is, this is how it looks. So it comes, if it is parallel to the principal axis, it is converged and it passes, or it is refracted and it passes through the principal focus. Then there is this ray that appears to be, that is parallel to the principal axis. So for it, when it is passing through this diverging lens, it is diverged and it appears, that's why it is a virtual ray. A virtual ray appears to be passing through the principal focus. So that is our rule number one. So we are going to see this rule through animations. So we are going to see animations using Fate. So let us see this also. Okay, before Fate, let us first finish all the rules. So that is rule number one. So rule number two, that is the ray. So we are going to start with the convex lens. So this is the ray that passes through the focal point. So if the ray is passing through the focal point, that ray, when it is through the lens, it is refracted, but it is refracted when it is parallel to the principal axis. So it is the reverse of the other one. As you can see also, this one, it is passing through the focal to the diverging lens. So it is also refracted when it is parallel to the principal focus. So that is rule number two of the important rays. So we have rule number three. So rule number three is also this important ray. And this one, by the way, we use it in each and every ray diagram. This is a ray passing through the optical center. So when a ray passes through the optical center, it is not deviated at any, so it just passes through the optical center and deviated. And it is the same case for both lenses, either convex or concave. So that ray is very, very important in the formation of ray diagrams, as we shall see when we are drawing these diagrams. So don't take it for granted. You master it very, very well. Yeah, so now let's directly go to what has brought us today. So we are going to look at images formed by convex, in brackets, converging lenses. So the nature of the image formed depends on the position of the object from the lens. So on the principal axis, as we saw the other time, there are different positions. So there is 2F, one can be beyond 2F, another one can be at F, another one can be between 2F and F, another one can be between F and the optical center. So it depends on the where exactly it is placed. So let us start with this case. Okay, before that, we have important links in this about this topic. So we can use fate simulations. We have YouTube. So in your free time, you can follow those links and really you see how they work. But for specifically for this lesson, we are going to see fate simulations at each and every step. So they will be included in this lesson. So let us see part A. We are going to see an object when the object is placed beyond 12. So this is F, this is 2F. So the object is beyond 12. So what is the nature of the image that is formed? So when it is placed at this point, we have this important ray that is close, and so you put these rays, they originate from the top of the object here. So this one is the ray which is part of the principal axis. So when it is here at the principal focus, this ray is refracted such that it passes through the focal point and is like this. Then this ray that is passes through the lens undeviated. So where these two rays meet, they form there an image. So let us, we are going, so what are the characteristics? So the image is between F and 2F, as you can see this image I. The image is real. It is formed by the actual intersection of light rays. It is inverted or upside down. It is again diminished or smaller than the image. So let us see some fate simulations concerning this. So this is fate, which is going to show us animations of how images are formed. We can change the objects. This is a pencil. We can put a penguin. We can use an arrow. We can use a source of light, anything like that. We can use a star. So anything, but for this case, let's use an arrow. So initially it is like this. So these are labels. We have the principal axis. These are labels on the principal axis. We have 2F. We have the object. We have the focal length, our lens, our focal length, and the rest. So we can try putting rays. So those are rays. So if rays come from the top of the object to the lens, so where they converge after refraction, there is a real object that is formed there. So initially rays can be like this. So these rays, they originate from the object when they are very many, but some do not make their way through the lens, so they continue their own path. These ones which passes through the lens, they are the ones which help us to make this image. Then when we use the principal rays, exactly these are the rays that we use. This ray which is parallel and close to the principal axis, it is a must, it must pass through the it must pass through F. This is parallel. Then this ray which passes here undeviated, you can see. Then this one which passes through the focal, it must go when it is when it is about the principal axis. So where these three important rays meet, they form there an image, as we can see. This image, its characteristics, we can see. If you asked about characteristics of this image, we can say this image is real. This image is real because it is formed by actual intersection of light rays. Again, we can say this image is real. Secondly, we can say it is inverted. You can see this image is inverted. It is formed between f and 2f, and really when we see in the size, it is smaller compared to the object. Let us increase the object. So I think we can see when we increase the size of the object, the image is smaller. Then as we then you can see, so this image is diminished. That's the term we use to mean that it is smaller than the object. So that's how the ray diagram looks like when the object is placed beyond 2f. So if you can put the 3D diagrams so you can see, still it must be upside down as you can see there. Then if we use marginal rays, these are rays which are somehow far from the principal axis. For them, after diverging, they can pass at any point. It does not necessarily mean that they should pass through the focal. So they pass at any point, but they still converge here to meet here and form the image. So those are marginal rays. But today we are dealing with principal rays. So that's it when the object is beyond 2f. Okay. So beyond 2f, we have seen the image is between f and 2f. The image is real, it is inverted or upside down, again diminished, smaller than the object. So from 2f, we directly go to when the image is placed at 2f, exactly at 2f. So when it is placed exactly at 2f, you might wonder what happens. So for this case, what happens here, it is that the object, here we have a ray, which is the principal ray, which is parallel and across the principal axis. So it is refracted and passes through F. We have this one, which passes through the optical center. It passes through and deviated again. These ones meet at 2F. So characteristics of this image, it is formed again at 2F. It is a real upside down, and again it is as of the same size, exactly the same size as the object. So let us again see this using FET. Okay, this is the case where the object is at 2F. So we have seen the characteristics. It is the object is of the same size as the image, and it is formed at 2F. It is real, it is inverted. So these are the characteristics of the image that is formed. So that's how it looks when it has no any what. So we place it here. Even if we increase the size, the object and the image are the same. Even if you change so we can put different objects. So but let us use an arrow. So that's it. So now if we start putting our rays, so when they are many, it appears like that. So these are marginal rays. So it means many rays come, but others which don't pass through the lens continue in their path. Then these ones which pass through the lens, they are refracted and meet here to form our image. So today we are dealing with principal rays, one which is parallel to the principal axis, it passes through F. Another one which passes through F is refracted parallel, then the one which passes through the lens goes through and deviated. So where they meet, it is where the image is formed. So I think all the characteristics, you have seen them. Yeah, that's how that one works. So master the characteristics, and whichever position the object is put. So the size remains the same at all costs. Okay, so that's when it is at 2f. Yeah, so those are the characteristics as you have seen in FET. Now let us go beyond, okay, between 2f and f. And so between 2f and f, uh, this is the case, 2f, f. So our object is here. These are the principal rays. So if this ray that is cross and parallel comes, it is the same story, refracted through f. This one passes through and deviated. You can see the magic here. So now this one is, you can see the object that is the image formed, it is beyond 2f nature. It is real because it is formed by actual intersection of light rays. It is inverted upside down, and again it is magnified. This one is bigger than the object. I think you can see that. So let us use FET. We are going to use FET to see how this really happens, how everything happens. So let us now record using FET. So okay, let's move our object closer to between f and 2f so you can see what is happening. So when there is no any ray, it looks like that. So you can see that the object is smaller compared to the image. So now when we are dealing with many rays, you can see, so these ones are not passing through the lens, they continue in their own path. And these marginal rays, you can see what happens. Then when we are dealing with the principal rays, which we are dealing with today, the one which is close and parallel passes through the focal, the one which passes through the focal is refracted when it is parallel to the principal axis. Then the one which passes through the optical center goes through and deviated, and the image is formed there. So the characteristics, so those are the marginal rays. They don't necessarily pass through the focal, they pass through at any point, but they also converge at that point to form the image. So even if you change the size of the image, you can see the magic here. As long as it is between f and 2f, that will always happen. So those characteristics are seen every time the object is between f and 2f. So master that very well. So from FET, those are the characteristics you have seen. The image was beyond 2f real, inverted, magnified. In other words, it is bigger than the object. So note that also, it is important to know. So let us proceed to what happens when the object is placed at f. So when it is placed at f, the image, by the way, is formed at infinity. In other words, our principal is this one which passes through the one which is parallel and across the principal axis. This ray will pass here in f, then this one also, but we shall find that these two rays are parallel, so they will never meet. That makes our image to be produced at infinity, and it is magnified. So let us see this, how it happens. So when we are using FET, let us use FET to see how this happens. So we are going to move our object to F. Yeah, I think you can see. Okay. So these ones will never meet at any point. So okay, let's move our object closer So I think you can see the magic. So now these rays behave that way. Point is at the principal axis. So this shows that this one it is a sign that they will never meet. So that is how we can say the image is formed at what? At infinity. So that's how. So if we have our principal rays, yeah. So I think you can see. So they behave that way. Okay. So that is the image placed at the principal focus. So for this case, we say that the object it is formed at the image, sorry, is formed at infinity. So master that one very, very well for future references. Okay. So when we talk of a magnifying glass, this is what we mean if you have ever seen such. So these are magnifying glass. So we use it for different applications. You can see this one is using it to magnify the words in a Bible. If you get a chance even to go to your laboratory, you can ask for one and you magnify different things in the laboratory. So this is what we mean by a magnifying glass. So away from that, let us see. So the image that is formed by this one, it is beyond 2f. It is virtual, upright, and magnified, and it acts as a magnifying glass at this point. Okay, so let us see how it forms. Yeah, so basically that's what happens when the object is placed at the at F. So that's it. So now let's change and look at something else. So now we are going to look at it. So the image is formed at infinity. That's what it means. So let's now go to when the object is between F and the optical center, and this is the meaning. So these are the circumstances where we say the lens acts as a magnifying glass. So right now, if it is placed at F, the image is formed beyond 2F, it is virtual upright and magnified. How does this one happen? So this ray, which is the principal, the one which is part of the principal axis, it converges through F, or it is refracted through F. Then this one which passes through from the object through the optical center. Here when we go this side, we see these two real rays cannot meet. So now we have to produce a virtual rays which meet here and end up forming a virtual image. So such circumstances, the lens acts as a magnifying glass. So these ones, we use it as a magnifier for simple objects like a house fly, what so. These are the cases where we use this lens for, as we are going to see here. So yeah, so now let's proceed to the formation of images in concave lenses. So here we need to note that for all positions of the object or the image formed by a concave lens is always virtual, upright, and diminished. So for this lens, irrespective of where you place your object, the image that is formed has only these three characteristics: virtual, upright, and diminished. It happens like this. So a ray which is close and equal to the principal axis, it is diverged and appears to be passing through the focal. Then this ray, which passes from the object through the optical center, goes through and deviated. So where these two rays meet, form there this upright image that is virtual, that is upright and diminished. So let us see how it is formed using PhET. So these are the PhET simulations for this type of lens. So this is the diverging lens. So let us choose our, so if we use principal rays, so a ray which is parallel and across the principal axis, if it is parallel, it is diverged but appears to be passing through the focal. Then this ray which passes through the object goes through and deviated. So this one, so where these two rays meet, it's where this virtual image is formed. So irrespective of the position, the image that is formed is of one kind. So it is virtual, diminished. So it is virtual because it is formed by apparent intersection of light rays. So that's how it is formed. Okay, yeah. So that is how we deal with these lenses. So in particular, that is the nature of the object, that is the nature of the image that is formed, virtual, upright, diminished. Members, this brings us to the end of our lesson. Thank you for attending. May God bless you. Wish you the best. Thank you.